Okay, so let's move to 7.3. So this is finding confidence interval for mean when sigma is unknown. Remember, in previous section 7.2, we were able to find the confidence interval for mean when sigma is known. Now the second case is finding confidence interval for mean when sigma is unknown. Okay, well, if sigma is unknown, so then what kind of, the formula we are going to use here? So here we are going to introduce one new distribution, which is called the T distribution. Okay, T distribution is kind of similar to a Z distribution, normal distribution, but in some case, in some sense, there's a difference between these two. So we are going to look at about the characteristic of a T distribution. So T distribution is a bell-shaped curve like a Z distribution standard normal. It is symmetric about the mean. The mean, median, mode are equals to 0 and are located at the center of the distribution. This is exactly like a standard normal distribution. The curve approaches but never touches the x-axis. So this all satisfied like a normal curve you could think of. So it will be like that. Okay. So this is my t distribution now. I am denoting by t. So the midpoint is now 0. Okay. Looks like normal distribution, standard normal, right? Then what is the difference between this curve and this standard normal? Remember, in the standard normal, the variance is always 1. But here, the variance is always greater than 1. The t distribution is actually a family of curves based on the concept of degrees of freedom. The t distribution curve is always depends on the degrees of freedom. Degrees of freedom is defined by looking at your sample size. Okay, so the degrees of freedom in this case we use as the degrees of freedom is just a number. That number is given by n minus 1. That means the sample size subtract 1. Okay, so if you want to use the t distribution things, and first of all, you should know the degrees of freedom. Once you have the degrees of freedom and alpha value, now we know how to find the t value. Okay, so look at the third, the difference. As the sample size increases, the t distribution approaches the standard normal distribution. When you increase, your sample size, so your t distribution curve finally will, approach the z distribution curve. Okay, so look at this formula. So this is the formula we are going to use to find the confidence interval for mu when sigma is unknown. Remember, in the earlier formula we had a sigma and the z, but now instead of sigma and z, we are going to use the t value and what is this? The sample standard deviation. Okay, right. So now the assumptions for finding the confidence interval for this case is again like earlier. We have a couple of assumptions. The sample is random sample, and or you could have either 30 or bigger, or the normal distributed when n is less than 30. Okay. Now, okay, let's look at this example. A random sample of high temperature for 12 recent Thanksgiving days had an average of 42 Fahrenheit degrees. Assume the variable is normally distributed and the standard deviation of the sample temperature was 8 Fahrenheit. Find the 95 confidence interval for the population mean for the temperature. The question is finding the confidence interval for the population mean. Well, ask yourself, do you know the population variance for this problem? Look at the problem. It is not known. So you don't know the population variance. Instead, they talk about what? The sample. Okay, so they have given sample standard deviation, right? That is 8. So therefore, I'm going to use now, since I don't know sigma, I'm going to use the confidence interval formula. So before going to do that, let us summarize, the things given in the problem. So if you look at the problem, the sample size is 12. So n is 12. And the x bar, the mean for the problem is the average is given 42. What else you know? I know the sample standard deviation little s is now 8. Okay, remember, so we are going to use the confidence interval formula for mu when sigma is unknown. Formula says that it is x bar subtract t alpha over 2 times little s over square root n, then mu less than x bar plus t alpha over 2 times s over square root n. Remember, like in 7.2 section, here also we are going to find, the t value. There we found z values. Now we are going to find here t values. Okay, right. So remember, first of all, you need to figure out the alpha. So the confidence level is 95. Therefore, alpha is 5%. Okay, it is 0.05. Okay, so I'm going to tell you how to find the t values now. T alpha over 2. Okay, so let me draw first t distribution curve. This is my the region of confidence level. So it is given 0.95. Therefore, the remaining is alpha over 2, which is 0.05 divided by 2, which is 0.025. That side also should be same, alpha over 2.025. Okay. Now here we are going to find the T alpha over 2 negative and T alpha over 2 positive. Because of the symmetric, we'll get same values with a different sign. Okay. Now we are going to use the different table here. We are going to use T distributed table. So it is there in the table. You have to use the table F. Remember, table E was a standard normal distribution table. Now we are going to use the T distribution table. Okay. Remember, we need to know first the degrees of freedom, right? What is the degrees of freedom for this problem? Degrees of freedom is given by n minus 1, sample size subtract 1. The sample size n was 12 for this problem, therefore 12 minus 1, which is 11. Okay, so the degrees of freedom for this problem is 11. But remember, this is the way to find the t value. It has so many columns here, rows, and now unlike in z distributed table, here, we are looking for t value once you know your right side area of the region. Okay, so keep in mind that, so when you use a t distribution table, you have to look at, the right side area. You should know the right side area for the corresponding t values inside the table. So inside the table you will have all t values, then this is corresponding degrees of freedom, and here you will find the confidence intervals. Okay, so first of all you need to find the alpha, then according to that you need to figure out the t values. Okay, so let me explain somewhere here. So when you use t table, how do you find the t value? You should know the right side area to the point. Okay, suppose if this is the area, say suppose this is alpha, then this point is going to be my t of alpha. Okay, so what I'm trying to say is you need to figure out always right side area to the point, then the table will give you this t alpha once you know your alpha value. Okay, now if you look at this picture, so if you compare these two pictures, I could find out T alpha over 2 if I know the right side area to that T alpha over 2. Yes, I know the right side area of T alpha over 2 is this side, this region, which is alpha over 2, that is 0.025. Okay, therefore you have to look for 0.025 with degrees of freedom 11. So go back to your table. Okay, I have degrees of freedom 11, but you need to look for 0.025 in one side, because I'm considering one side at a time. Therefore, I'm going to look at 0.025 with degrees of freedom 11. So where's that? It is going to be, you look at here, you look at the one side tail, and the 0.025, which is, where's that? It is 2.201, right? So this is the value we need. Okay, 2.205. My T alpha over 2 is 2.201. Okay, so make sure that you understand about the table, how to find the T values when you know the right side area to the point. Okay, well, we know now all the numbers. Plugging into your formula, you will get the confidence interval. So let us find out that then. So x bar is 42, subtract T alpha over 2 is 2.201 times sample standard deviation is 8 over square root n is 12. So less than mu, then x bar is 42 plus 2.201 times 8 over square root 12. Okay, so simplify this one, and if you simplify, you should get 36.9 less than mu less than 47.1. Okay, so that is the confidence interval. But anyway, so you could use the calculator here as well. So I'm going to show you how to use the calculator for this finding a confidence interval. Remember, now I'm going to use the t values, right? Therefore you have to pick the different function now. So go to stat, go to test. Now I'm going to pick a t interval, that is number 8. Okay, so you need to understand, in which situation you have to use t. You could use t interval when you do not know population variance, okay, or population standard deviation sigma. Okay, so now I'm going to put the stats here for this particular problem. X bar is, what is x bar? 42. And yes, sample standard deviation is now 8. And the n was 12. And the confidence level is 0.95. Enter. Just so it's giving 36.9 exactly, 47.1, right? So our answer is correct. Okay, so let me write down that step somewhere here. Okay, now let's look at example 2. The data represents a random sample of a number of home fires started by Kansas for the past several years. Data from the National Fire Protection Association. Find the 99 percentage of confidence interval for the mean number of home fires started by candles each year. So if you look at here, 1, 2, 3, 4, 5, 6, 7 data values are given. Now this is, I don't know anything about the means, the sample standard, nothing was given. Just the raw data is given. Okay. Only thing is, by looking at this problem, you know that the confidence level is 99. This value is useful to find out the alpha, right? But other than that, remaining all, the summary of your sample should be based on these values. Okay. So if you look at the previous problem, already everything was given, right? The sample mean, sample standard deviation. But the raw data was missing here. But now you are given the raw data. So there are two ways. First, you could find the sample mean, the standard deviation by entering this into your calculator, or manually find x bar and little x first. Then you could use the formula like earlier. Okay, so I'm going to show in either way, by using calculator and by using the formula. Okay, so let us find out first the sample mean and the standard deviation. So I'm going to enter all the data values into our calculator. So I'm going to stat. Let me clear this first. I'm going to enter all the data values: 5460, 5900, 6090, 6310, 7160, 8440, and 9930. So I have entered all 7 data values. Now I'm going to, calc one var step, enter. Okay, so I got a bunch of summaries about my data set. So let me write down those things. So X bar is 7041.24, and I need now the sample standard deviation, which is 6010.3. Okay, so I need that, and the sample size was 7 for this problem. Therefore, the degrees of freedom is 7 minus 1, which is 6. Then what is alpha here? If you read the problem, alpha is 1%. That is 0.01, right? Okay, so I know everything. So the confidence interval formula is what? X bar minus T alpha over 2 times S over square root n less than mu less than X bar plus T alpha over 2 times S over square root n. Okay, you need to figure out now only T alpha over 2. So let me draw a picture here to find out T alpha over 2. Remember, I need to know now right side area. So this is alpha over 2, and this side also alpha over 2. Okay, so alpha is 0.01, therefore alpha over 2 should be 0.005, and this side also 0.005, right? Okay, right, now you need to figure out T alpha over 2, remember? Okay, so I need to figure out T alpha over 2. You remember the right side area is now 0.005 with the degrees of freedom 6. So 0.005 with 6. Go to your table. Need degrees of freedom 6 and 0.005 under one tail. 0.005 is the last column. So look at for this, the value degrees of freedom 6. So it is 3.707, 3.707. So my T alpha over 2 by using the table is 3.707. Okay. I know now T alpha over 2, plugging everything here, you will get the interval now. Therefore, my interval is 7041.4, subtract 3.707 times S is 6010.3. Okay, this all divide by square root of n is 7, then less than mu, less than 7041.4 plus 3.707 times 6010.3 over square root 7. Okay, now take your calculator and simplify these two. So if you do correctly, you should get 4785.2 and 9297.6. Okay, but let's look at how to use the calculator directly without doing this work. So I'm going to test. Now I need to choose number 8, T interval. Remember now, I'm going to enter the raw data without doing anything. Therefore, I'm changing the option to the data now. Enter. Once you change that to data, it will ask you to, where did you type your data set? It will ask. So remember, we entered all the data values into L1 column. So keep that in L1. The frequency, keep at 1. C level, the confidence level for this problem is, remember, 99. So you need to change the confidence level to 99.99. That's it. Just enter. So my answer 4,785 and 9,297.9, very close to this answer, right? Therefore, you could use either, either calculator or the table to find out the answer. Okay, so this is the time for you guys to practice and make sure that you understand everything. Okay,